This is our One to the World project. I'm Sean Akram.
Alex Stone.
And I'm Hashir Fahim.
So this is our problem.
Tom tricked Jim to the top of a 20-foot ladder leaning against the side of a building. Tom began pulling the ladder away from the building at a rate of 1.5 feet per second. When the ladder is 8 feet from the building, how fast is Jim plummeting towards the ground?
So the fact that you have a ladder leaning against the wall means that you can assume that you're dealing with a Pythagorean theorem rate of change problem. So if you set it up, here's Tom, here's Jim, this here is the ladder, this is the ground, and this is the wall. It forms a right triangle. So in the problem, here are your givens. You are given that the y value, or the height value in this, is going to be 8 feet. The length of the ladder, or r, is going to be 20 feet. But then you have to find the x, the how far along the length of the ground it is when he's at 8 feet up the wall. So to do that, you would set up the Pythagorean theorem. R squared equals y squared plus x squared. You would plug in your values, so you're given r, 20 to the power of 2, equals, you're given y, 8 to the power of 2, plus x to the power of 2. So 20 squared is 400, 8 to the power of 2 is 64, plus x squared, minus 64 from both sides, you're given 336, equals x squared, take the square root of both sides, x equals square root of 336. So that gives you your x value, and that puts you in pretty good shape to find dy dt, or the rate at which Jim is falling towards the ground.
So now that we've solved for x, we can use our Pythagorean theorem again in order to get dy dt, the rate at which Jim is falling. So when you take the derivative of this formula, you have to also do chain rule, which gets you 2 dr dt times r equals 2 dy dt times y plus 2 dx dt times x. Now we know dr dt is 0 because the length of the ladder doesn't change at all. Then we plug in what we're given, which is that the height is 8 feet, and then we add that to 2 times the rate at which x is changing, which is 1/2 feet per second, times the length of x, which is the square root of 336. So that means we get 0 equals 16 dy dt plus square root of 336. We subtract the square root of 336 from both sides, we get negative 336 equals 16 dy dt. Well, now what we have to do is divide by 16 to both sides, and then we get that the rate at which Jim is falling is negative 1.146 feet per second.